All right, round two, linear motion with constant velocity. We're going to talk about the difference between distance and displacement in this round. It's a small difference, but there's an important one. So how we're going to start is with a little picture, right? Just like we have in round one. We have position x1, that's where you start. Position x2, that's where you end. And what I want you to do is connect the start and finish position any way you want, but no straight lines. And you'll compare with your neighbor, in this case, Professor Ray. And what I want you to do is label your path D. And after you've completed it, press yes. All right, so here's gonna be my path. I'll say, hello, exclamation point, exclamation point, exclamation point. Boom, there we go. So hello, everybody. So we have my path here. I'll label my path D, I guess. Whose pencil went the farthest distance? I'm gonna guess mine. Maybe you did something a little more crazy. Maybe it's yours. But how do you know? Well, the person who drew the longest line, whoever used the most ink, whoever used the most marker, whoever used the most crayon, if you're using crayon, whoever used the most graphite, the most carbon, the most pencil, right? Whoever used the most stuff, whoever made the longest line, that is the line that is the biggest distance. Pretty straightforward, okay? Now, if we only cared, right, about the initial and final points, though, right, we may say the distance traveled doesn't matter, right? I don't care how far you walked, right? I just care about that straight line distance between the beginning and the end, which would look, hence I said no straight lines before. I'll do this right here, right there. And there's my straight line distance. We would call that right there my delta x. So I'm going to label this delta x, right? So D, distance, straight. It doesn't matter how you get there, right? You can have a long distance, you can have a short distance, right? But if you happened to walk in a straight line, right, we call this a special distance, right? We call that displacement, and we call that my delta x, right? So you draw that straight line, start at 1, end at 2, and we'll label that path delta x. And technically we can even put a little arrow here too, right? Arrow. You started at 1, you went to 2. This is called displacement. So how do all of our displacements compare, right? The one that I did, the one that you did, if you're with somebody else, what your neighbor did, right? All the displacements are the same, right? Distances could be different, but the displacements of everyone is the same. It's that straight line distance. So now you see that one special scenario where displacement and distance are the same. A displacement is kind of inherently always has a distance. It's the straight line distance from 1 to 2, right? But distance doesn't have to be a straight line. You could write hello, you could go on a nature walk, etc., right? So generally, this is the difference between distance and displacement. Distance cares about the whole trip. It cares if you went that scenic route or not. But displacement only cares about that straight line distance from when you started to where you end. So the distances traveled for all students, dare I say all students, was different. Right? Or should I use this? And the displacement for all students was the same. Maybe that will help people in terms of my writing. Not that my cursive is terrible, right? But maybe I'll do the text. Okay, I'm going to delete all this here. You can always go back if you need to, clear all the drawings, because we have one more problem to go before we hit up round 3. All right. An ant is crawling along the floor, follows a semicircular path going halfway around the circumference of a circle of radius r. The distance traveled and the displacement of the ant respectively are. So that means when you're writing this, all these numbers here, right, those are delta x's. Which one is the correct delta x? And all of these other numbers right here, this is what we're saying is the distance D, right? Give it a try. All right, hopefully give it a try, and let's talk about it. This one right here, if you know what you're doing, go ahead and move forward, right? If you don't, well, yeah, go ahead and move forward. But right here, this is where you started. There's x1, there's x2. I told you those pictures are super helpful, right? So this right here, that little arch right there, is that distance or is that displacement? Think about what we just did, guys. This right here is your, I hope you said distance. I really hope you said distance. Okay, the distance you went is half a circle. Well, if the full circle is 2 pi r divided by 2, because you went halfway around, it leaves you with pi r, right? There's a lot of different pi r's there. Well, but at least you know B is not the right answer. So what are we left with? Displacement. How do you draw displacement? Straight line distance. I knew some of you said that. All right, straight line distance right there. What does that look like? It looks to me like the diameter of a circle. Diameter would be, well, radius is half the diameter. That would mean you've gone 2 radiuses if you've gone the full diameter, right? If that doesn't make sense, right? There's R, 1R plus 1R is 2R, right? So that leaves us with the thing that was punched as the right answer, which is C. All right. Whew. Okay, let's keep going because round 3 looks like it's going to be just as fun.